Did you know that in the last year, a robot learned how to fold laundry just by watching videos online? It observed countless hours of human hands folding towels, shirts, socks, and then replicated the motions with its own mechanical grippers. This isn't science fiction. This is the reality of artificial intelligence in September 2025. We are standing at the threshold of a new era, where robots are no longer just pre-programmed machines executing repetitive tasks. They are beginning to perceive, learn, and adapt to the world around them. The progress is happening faster than many predicted. This essay will explore the incredible progress we see in AI robotics. We will look at how these machines make sense of their environment. We will break down how they learn new skills and make independent decisions. Real examples in factories, hospitals, and even moving toward our homes. The core idea is simple. AI is the brain, and the robot is the body. For years they grew apart. Now they have collided. We are witnessing a shift from automation to autonomy. Navigate, assist, even provide companionship today. For a robot to act intelligently, it must first understand its surroundings. This begins with sensors, the robot's senses. High-definition cameras act as their eyes, capturing visual data. Microphones allow them to hear commands and recognize sounds, but they also perceive beyond human capability, turning everything into data. One key sensor is LiDAR, firing millions of laser pulses per second, measuring return time, building a precise 3D map. Crucial for complex spaces, a busy sidewalk, a cluttered room. Fused with cameras, LiDAR tells where things are, their shape, and relative position. Touch is becoming vital, sensing pressure, texture, temperature. Handle delicate objects without crushing. Fine motor tasks, keys, clothing, beyond simple pick and place. All signals flow to onboard compute, forming maps, identities, and feel. Perception is the bridge to the robot's digital mind. Once a robot perceives the world, it needs to know what to do. This is where AI-driven learning comes in. Many use machine learning, learning from examples instead of hard-coded steps, show thousands of successful grasps, real and simulated. Through trial and error, with rewards and penalties, policies emerge that even surprise human designers. Imitation learning lets robots watch and replicate human movement, from wiping a table to making coffee. At runtime, trained models choose actions from live sensor input. A person requests a bottle of water, it plans a path, opens the door with measured force, identifies the right object. This loop, from perception to action, happens in fractions of a second, enabling fluid, responsive interaction. Learn, decide, act continuously, always anchored by what the sensors reveal. Different methods, one goal, competent autonomy, and that's how robots decide today. So, what are intelligent robots doing today? Their impact is most visible in structured environments, factories and warehouses. Fleets of mobile robots shuttle inventory to humans, drastically speeding order fulfillment. Cobots take on repetitive, physically demanding tasks, freeing humans for quality control and dexterity. In hospitals, autonomous carts move medicine, samples, and linens, reducing walking for staff. In the OR, surgeon-guided systems enable precise, less invasive procedures. Legged robots like Spot traverse rough ground, climb, and inspect dangerous areas, extending our reach for inspectors and first responders. Service robots engage the public with info and guidance. At home, vacuums map and plan cleaning intelligently. Ambitious humanoids aim at general-purpose assistance, foundations under test today. Factories, hospitals, research, homes, the useful is already here and expanding. Next, movement and touch. The jaw-droppers, and how they actually work. One of the most stunning advances is mobility. From clumsy steps to agile, robust motion. Leading platforms now walk, run, even do simple parkour. AI-driven control and rich sensors maintain balance in human environments like stairs and mess. Dynamic stability, controlled falling caught each step. Controllers read gyros and cameras thousands of times per second, reacting to pushes or slips in real time. That's how you get forest jogs and backflips. Manipulation advances, more fingers, compliant materials, tactile sensors, from soft toys to heavy tools with the right force. Vision infers shape and fragility to plan safe grasps. Now, language models tie it all together with natural commands. Parse the sentence, find objects, choose actions. Vision locates. Motion planning executes the sequence. This fusion makes robots truly useful collaborators. Mobility and touch, the pillars of capability. As robots enter daily life, safety is paramount. Protocols are built into core design. Virtual safety zones slow, reroute, or stop to avoid collisions. Motors respect force limits to minimize injury risk. Thousands of lab hours and realistic simulations push limits, exposing hardware and software failure points. Industry standards and certification will guide safe rollout. Limitations remain: novel settings, lighting, social nuance. Ultra-fine dexterity and common-sense reasoning are hard. We are still at the beginning. Data bias can lead to unfair behavior across contexts. Jobs, privacy, and autonomous weapons demand scrutiny. Responsible teams engage ethicists, policymakers, and the public. Safety-first development is non-negotiable. Respect the boundaries and the benefits will follow. Next, partnership and progress. The story ahead. Looking ahead, this is not a story of replacement, but of partnership. Humans and robots, each leveraging unique strengths. More cobots on floors and in workshops. In healthcare, logistics shift to robots, while nurses spend more time with patients. Next, easier training with low-code and no-code tools. Teach by demonstration or spoken instructions. Show once, repeat perfectly. Democratization unlocks personalized applications, accelerating adoption. Robots perceive with superhuman sensors, learn by trial and example, move more agilely, and handle with finesse. They are powerful tools, not sentient beings, bound by training and safety constraints. Dramatic demos come from years of steady incremental work. Expect steady steps, not sudden sci-fi leaps. The key is responsible development for human well-being. The new age of intelligent machines is here, its story just beginning.